So, 1.6, describing pairs of angles. How can you describe angle pair relationships? We talked about some of this yesterday. Two angles that add up to be 90 are called complementary angles. I think complementary corner. So remember, a right angle makes a corner. So, let's see, I'm not writing right now. So, I'll plug in my Apple Pen. All right. Here we go. So, what I mean by that is that right angle makes a corner. Unfreeze this, that would be helpful. So when we have two angles that add up to be 90 degrees, which we denote here with the little box, then those angles are said to be complementary. They can be next to each other, in which case we call them adjacent angles, or they can just be two separate angles, like angle A and angle B here, but they can still add up to 90, and they're still considered to be complements. So complements can be adjacent meaning next to, or they can be two separate angles. Supplementary angles, remember, those are angles that add up to be 180 degrees. So a straight angle forms a straight line, and all straight lines measure to be 180 degrees. We think of that semicircle. And then two angles, whether they're next to each other or not, that add up to be 180 are said to be supplementary. So they both start with S, and they're related. Supplementary is two that add up to be 180. A straight angle is a single straight line or segment whose degree measure is 180 degrees. Complementary and supplementary angles can be adjacent. Remember, we said adjacent was next to, or non-adjacent, so they can be entirely separate angles. They share a common vertex and side, but have no common interior points. So if we look at the diagram here, they have this common vertex. Remember that a vertex is formed by two rays, right, that come together to form an angle. So both angle 5 and angle 6 have this common vertex right here. And then we can name it with angle 5 and angle 6. They have a common side, which is highlighted in blue right there, but no common interior points. All that means is that the interior here and here are not the same. Does that make sense? With adjacent angles and supplementary angles and complementary angles. On your first test, I will say, here is 30 degrees is a complement of what other angle? What would you say? What does the other angle have to measure to be a complement for 30 degrees? 60. So 60 and 30 are complements. 100 degrees and 80 degrees are supplements. So you'll have at least 2 questions that ask that on the test. So on the slide, it says, in the figure, name a pair of complementary angles, a pair of supplementary angles, and a pair of adjacent angles. So let me blow this up here. So looking at this, name 2 angles that are complementary. What's one of the angles? CAB. Angle CAB. Remember, the vertex is in the middle. What is another angle that's complementary to that CAB? Yes, TSR. Remember, you always have the vertex in the middle. TSR or RST. So the 2 of them are complements, because you can take 37 and add it to 53 and get 90. So again, don't mess up on the test with that vertex. The vertex has to be in the middle when you name it. Name two angles that are supplementary. CAD and RST. Angle CAD and angle RST. Name two angles that are adjacent. CAD again, or DAC, same angle, right? CAD and DAC are the same, so I'm just going to name it DAC. And what's that adjacent to? BAC or CAB, either one's the same. So BAC. Dock and Bog. Okay. What's the measure of angle 2? So yes, because we subtracted from 90. What's the measure of angle 3? 133, because we subtracted from 180. Okay. So angle 3 and angle 4 are supplementary angles. All right. We're not going to do all of this. I just want you to answer question 2. So let's just look at this together. It says our angle KGH, and again, I always mark everything. KGH, G's in the middle, so that's the vertex. KGH is that angle right there that I marked in black. That's 131 degrees. Our KGH and LKG, so I'm going to mark LKG. That's this angle. Are they adjacent angles? Explain. Are the red and black angles adjacent? No. Why not? Adjacent angles have to be next to each other. And for two angles to be next to each other, they have to share a common what? Yeah, common side and vertex. Right. Vertex. That's perfect. So they do not have a common vertex. This has a vertex of G. This has a vertex of K. So no common vertex. No common vertex. Do you have questions so far? No? All right. Let's see if you can do this one on your own. You can just put example 3 on the side of your notes. And if you have a book out, try not to look at it and see if you can do it on your own. All right, so right now we have linear pairs of angles. If you didn't see the side margin, that just said other angle pairs. So, straight angles are angles that measure 180 degrees. They form a straight line. Supplementary angles are two angles that add up to be 180 degrees. They may be next to each other. They may not be next to each other. It turns out that if supplementary angles are adjacent, they have another name, and that's called linear pair. So, but it's kind of all related, right? Supplementary, straight 180, linear line, a line is straight. So that's how I think of it all. So a linear pair are a pair of angles that are next to each other. They have that common side and common vertex right there. And they add up to be 180 degrees. I will ask you in a chart on your test to name a linear pair. If you give me two angles that are not next to each other that add up to be 180, you've not answered the question correctly. You've given me supplementary angles, but you haven't given me a linear pair. And I will use linear pair a lot. So linear pair are two angles that are next to each other that add up to be 180. The other word that you'll see me use quite frequently from here on out throughout the rest of the entire year are vertical angles. Two angles are vertical angles when their sides form two pairs of opposite rays. Vertical angles are extremely important in geometry, so you need to recognize them. Vertical angles are always, I think of it as angles that are across from each other. They form an X. So if you have angles that form an X, you are going to have vertical angles. 4 and 5 are across from each other, so they're vertical angles. 3 and 6 are across from each other, so they are vertical angles. And later on in the year, we will learn that all vertical angles are the same measurement. Questions on vertical angles. Can you identify vertical angles and linear pairs? Okay. So if I were to give you a math problem that had, let's say, 4x plus 1 and 2x plus 3, and I said that you have vertical angles here, obviously because they are across from each other, you'd note that they were the same. If you had to solve for x, you would set them equal to each other. Does that make sense? Because they're the same measurement. So if this is 30 degrees, this is 30 degrees. Okay. Which, in the grand scheme of things, it would make sense. Because if this forms a linear pair, 4 and 6, what would angle 4 have to be? If 4 and 6 form a linear pair, right here, they form that linear pair, what would angle 4 have to be? The measure of angle 4? 150. And if this is 150, this is 150. And that makes sense because we have another linear pair right here. Does that make sense? Okay, excellent. Try this one on your own. So looking up here, I have one pair of vertical angles. What are they? 1 and 5. Because 1 and 5 are the only ones that are directly across from each other. Right? 3 and 4 are not vertical angles. They have to be directly across from each other. So if I look at this, let me unfreeze it. That's what I have. My vertical angles. So angle 1 and angle 5. Now, if I was looking at angle 4 forms a linear pair with this angle, but not with just 3 or just 2. Does that make sense? All right, so let's look at linear pairs. What are our linear pairs here? 1 and 4, somebody said it. 1 and 4. Yes, angle 1 and angle 4. So if I look at this in black here, I have that straight line, that semicircle with this straight line there. So angle 1 and angle 4. And then what's my other linear pair? Well, it wouldn't be 2 and 5 because 2 and 5 have to be right next to each other. Let me erase the markings. Four and 5. 4 and 5. 4 and 5 are adjacent. They have a common side, which is right here, a common vertex in the middle, and they add up to be 180 degrees. So angle 4 and angle 5. If you look at 2 and 3, it's that's not a straight line. Does that make sense? Questions? 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 No? All right. Example 5. Almost done. Then we're going to look at your quiz. Finish it up. Two angles form a linear pair. The measure of one angle is 5 times the measure of the other. Find the measure of each angle. So if they form a linear pair, they add up to be what? 180. Here's one. I don't know it, but I know that one of them is 5 times the other one. They add up to be 180 degrees. I combine my like terms. Divide by 6. X equals 30. So one of them is, say, angle 1. The measure of angle 1. Remember, when I say I'm going to set it equal to something, I have to put the m in front for measure. The measure of angle 1 is 30 degrees. The measure of angle 2 is what? 150. Because they're a linear pair and one's 5 times the other. Questions? Okay. You don't have to write this down, but I would look at it. You guys have a chapter summary, so make sure that you go over that chapter summary from here on out. That stable chapter summary that I gave you, that is going to be the best test review, other than the direct review that I give you on Tuesday or on Monday. On Monday. So do look at that. This just reminds us a couple things. For example, all the points on here are coplanar. They're all part of the same plane. It talks about which points are collinear, where they intersect, which ones are adjacent, what straight angle is formed, which point lies on the interior, things like that. So do take a look at that. Give that some time. Look over your chapter summary. How do you feel about the content for chapter 1? Is it okay? Yeah. Okay, great. Let's look at the last 2 problems on the quiz from last time. I forgot to add those questions on my slides here, so I'm just up from my computer, and then we'll take a look at it. So that last one was very tricky. So question 7 on your quiz that you took from before said that you have endpoints. You have an endpoint G, which is negative 3, 0. And you have an endpoint H, which is 7, comma, negative 8. And it wants you to find the midpoint of those endpoints. How do I find the midpoint of those endpoints? Anyone? Midpoint tells you to do what with the x's and the y's? What's step 1? Yes.
You angle the x and the y, 1 and y2, and then you plug into the.
That's distance. Well, it does have a formula, so say that louder. You do what with x's?
The formula is x plus x.
Yes. Right. You add the x's together. If you're finding the midpoint's in the middle, so you're going to add the x's together. And then you divide by 2. So that's 4 over 2, which is 2. I got that from the x's. And then you're going to add the y's together, 0 plus negative 8, and then divide by 2. Well, that's negative 8 over 2, which is negative 4. So what's your midpoint? And my battery's low, is 2, comma, negative 4. And then you can label that M for midpoint. Does that make sense? The last question was the one that got some of you, and that's probably why you got 7 out of 8. That was that find the perimeter of the triangle one. So let's take a look, and I'm going to show you a little trick for that one that I think will help you out. So for that one, you were given 3 vertices of a triangle ABC. So triangle A, B, C. You have vertice A, which is 1, comma, negative 6. You have B, which is 1, comma, negative 3. And then you have C, which is negative 4, comma, negative 6. I provided you a graph for a reason, but you actually didn't need a graph to do this. But let's just graph it anyways. I'm just going to do a rough sketch. I don't even need to be exact, and I'll tell you why. So I'm going to just label 6. 1, 2, 3, 4, 5, 6, positive 6. 2, 3, 4, 5, 6, negative 6. 1, 2, 3, 4, 5, 6, negative 6. 3, 4, 5, 6, positive 6. X and Y. Arrowhead, arrowhead. Okay, so I'm going to label these points on the graph. 1, negative 6. That's vertex, or that's the vertex A. And then I have 1, negative 3. And that's B. Right away, I see a vertical segment, which means what can I do to find that distance? Yeah, find the difference, right, and the absolute value of the difference. Now, I'm going to look at C, negative 4, negative 6. 1, 2, 3, negative 4, negative 6. And again, I have a horizontal length, so I can just subtract the difference, or I can just find the difference, not subtract the difference, find the difference and take the absolute value. It's BC that's difficult. I have to plug into the distance formula. So, without even graphing that, I could have known that it was just about finding the difference between two of my segments. How? Well, because I saw this is negative 6 and this is negative 6, right? And I also saw that this is 1 and this is 1. Okay? So, that would tell me right away that I can find those differences, and that'll give me the length. So let's look at AB first. The length of AB. I'm just going to look at the things that are not the same, which is these two right here, and find that difference. Negative 6 minus negative 3. What is that going to give me? Yeah, it's going to give me that negative 3, and then the absolute value of that is 3. 3 units. Does that make sense? And then I'm going to move on to the next one, AC. So AC, what do they not have in common? Well, what do they have in common? They have a negative 6 and a negative 6. So I'm going to find the difference of the other two, which is 1 minus negative 4. And that's going to give me 5 units. I saw several of you do that, which is great. You got the 3 units and you got the 5 units. It was the next part that was tricky. So now we're going to plug it into the distance formula for BC. Because this is a diagonal segment, I cannot just count. You could have just counted when you did the graph instead of just found the difference. And some of you did just count. And that's fine. So for BC, since that's different, I'm going to have to use the distance formula. You will have to have that memorized for your test. So, I will ask you a question that straight up use the distance formula, find the distance. So make sure you have that memorized. So BC, you're going to take the difference of your x's squared and the difference of your y's squared and add them together. So I like to start with my y's. It doesn't really matter which one you start with. So I'm going to do negative 6 minus negative 3 quantity squared plus negative 4 minus 1 quantity squared. Okay. So when I do that, so is everyone with me so far? Yes? Everyone's good? So when I do that, I add and I add, I get 9, right, when I square that. Because negative 6 plus 3 is negative 3 squared is 9. And then I get negative 5. Negative 5 squared is 25. And I get the square root of 34 units. So now, what's my last step? What's perimeter? Add it all up. So I'm going to add this up, and add this up. And when you plug this into your calculator first, and then you add 5 and 3 to it, you get 13 point something, 13.83, approximately 13.83 units. Even if you showed just this, I give you credit for the work. Some of you didn't get credit for the work because you didn't show anything. So make sure that you show something next time I say show work to get any sort of credit for it. Do you have any questions now on that quiz? Does it make sense now on what you missed? Just watch your signs.